record on this computer. All right, so what we're going to do today is we're going to extend the use of the normal distributions to another area. Well, actually, it's the same area. We're saying in the same vicinity. So I can say that we're going to be doing it backwards now. So last section, in section 5.2 and 5.2, I basically said, hey, listen, here's an X. Then you found a Z. And then with that Z, you referenced the area, which is in fact the probability, right? So now what our goal is I'm going to give you an area. You reference it to a Z, but you go back to the X. Remember, in this case here, when we went this way, the Z that we used was X minus mu divided by sigma. That's what you did on your quiz, right? Well, when we go backwards, we're going to find the Z by referencing from our table. But to go to the X, we're going to use X equals mu plus Z sigma. So I know some of you have some blank stares, but it's going to be obvious. It's going to be obvious how to do this. Thing is, you need some new terminology and things like that, but I think you should be fine. So let's first begin with, here's a normal curve. Yes. Unfortunately, there are some students that I have despised, and therefore they were able to get extra credit last 9 weeks, and I didn't want them to. And you got kids that don't deserve a B getting Bs. Therefore, especially when it's one of those, that you're almost willing to fail the whole class just to hurt them. That's why I don't want to give extra credit. Okay, no, but I'm so sorry. I know sports medicine is important. I have an injury in my left shoulder. All right, so let's continue. Does it make sense what I said? You know how crummy I felt giving some kids like a B last 9 weeks that deserved like a C for sure because of the extra credit? All right, so here we have a curve, and let's assume instead of giving you the Z score, I said, look, here's the Z. I don't know what it is, but I do know that this area here happens to be 0.9901. Could you find a Z score that corresponds to an area to the left or commutative area of 0.9901? Yeah, you gotta go to your table, your standard normal distribution table, and you gotta, instead of looking for a Z, you gotta look for the thing in the middle, right? So let's see if you can find it.
Give me that area.
Yeah, giving you the area. I'm giving you the area. You need to find a Z.
9901, right?
Yep. Can somebody zoom it in?
Right here, Messi.
Point what?
2.33.
2.33. All right, let me go ahead and fix that board. So this becomes now 2. I just put 2 o'clock. 2.33. That's your Z score. Super simple, right?
That's all we're finding?
Well, no, we are obviously gonna do something else. I wish it was that easy, but it's not. Okay. Fair enough. So far, so good, right? Now, give me 1 second. We're kind of gonna be doing that. So my ex plumber, one of the guys I used to hire for plumbing is calling me. So I'm thinking to myself, why? Is he asking me for money? Is he going to ask me for work? He's probably, or does he have a job that maybe he wants me to price and he gets a cut? So the thing is that I've heard bad stuff about him in the past like 3 months. So I don't know if I want to deal with him, but whatever. It's just, it's just gossip and innuendo and all right, doesn't matter. Okay, so let's continue our lesson. Now, what if I did this? Oh no, he's asking for the number of my brother-in-law. Allá va. This is not good because my brother-in-law doesn't like him at all. But I'm gonna go ahead and send it. Give me a second. I misspelled something in Spanish. All right, so let me give him the stuff. Okay. Salchicha de argentino. All right, so let's do another one. Phone's the worst thing that ever came to us. Okay, so now let's do the next one. Sorry about that, guys. Just let's say I gave you this one instead. I went like this. And I gave you that this area here is 0.0322. Could you find the z-score for that? No? What's so difficult about that? Yes, you would have to go 1 minus 0.0322. So this would come out to 0.9678. And now what will you look for? Huh? Yes. Go ahead, Melissa. You were asking a question. 1 minus that. So this here came about me doing 1 minus 0.0322. And the reason is because if the area to the right here is this much, then the area to the left must be 1 minus that. And now you go to your table and you look up 0.9678. 0.9678 comes out to 1.85. Now, just out of curiosity, and I think a little bit more in curiosity, I want you to go ahead and look up negative 1.85 and tell me what does it give you when you look up a z-score of negative 1.85. What area, what cumulative area or area to the left does it give you? What does it give you? Do you see something there? Do you see that the area to the left of negative 1.85 is equivalent to the area of the right of positive 1.85, and the area to the left of positive 1.85, the 0.9678, this one, right, is equivalent to the area to the right of 1.85. Do you notice that? And this is due to symmetry because both sides of the curve are the same. Got it? We're good? Okay, great. That's awesome. Okay, so now let's talk about a question that you would need to answer from this because we're not done. So let's say I give you the following question. Let me use a serious color. Here's the mean. The mean height of women is 54 inches. 1 inch shorter than me, 2 inches, 5'6", 5'5.5", whatever. And a sigma of 2. About right. Okay. So what if I said, listen, what heights make up? So what I said, what heights make up the 90th percentile? So I ask you, what height would the 90th percentile of women, I can swear I am, have? It's just going to show up very slowly. Internet. Oh, there we go. There we go. So what height would the 90th percentile of women have? So you can see that the 90th percentile, P90, right? 90th percentile. What decimal would that represent? What would 90th percentile be in decimal? 90th percentile. You know what area that would be here? 90% of the area. You write like this, 0.9000. You see that? So, you know, I'll show you other examples, but that's how you would write 90th percentile. And so could you find a z-score that corresponds to a cumulative area of 90% or 0.9000? How would you do that? How would you, if that's 0.9000, wouldn't you come to your table here and look to see where 0.9000 is in the areas and correspond that to a z-score? So it has to be a positive z-score. What's our problem here? There's nothing exactly 0.900. In fact, we have two of them, right? I'm trying to find it myself. Oh, I found it. We have for 1.28, we have 0.8997, and for 1.29, we have a cumulative area of 0.9015. The thing that we do here is we pick the closest one. Who's closest to 0.9000? 1.28. Do you see why it's the closest? Because 0.8997, the next number under it is 0.8998. Next one under it is 0.8999. The next one under it is 0.9000. Then you have 0.9001, 0.9002, and 0.9015 doesn't happen until 13 more down the line. So this one here is the closest one to this one. So therefore, our z-score here should be 1.28. It's the closest one. But are we trying to find a z-score, or do we want to find the x, the height? The x. So how do we find the x? It's very simple. It's very simple. X must equal your mean plus z sigma. What is my mean? 54. What is the z I just found? And what is sigma? 2. Now, you do the math for that. 1.28 times 2, right? We're going to do PEMDAS. That's 2.56 and add it to 54. This should come out to 56.56. The height of 56.56 inches represents the height, which is at the 90th percentile of the women. That means 90% of the women are 5'6" or shorter, according to this set of information. And it's a little bit off though, but in reality, but according to this data, it is. So this is how you do one of these problems. Now, where do you guys have issues? Well, sometimes you don't know what things mean. For instance, like, could somebody tell me what P50 would stand for? What does P50 stand for? 50th percentile. So it will stand for the 50th percentile. And could somebody tell me what decimal representation would that be? 0.5, and we should write it like this, right? And then how do we draw it? If I do this curve, where would I draw the 50th percentile? Right in the middle. And where will you shade? Left or right? Left. Because a percentile is a cumulative area. An area, I'll write it nicely. Let me write it nicely. Oh, you guys, if you want, you can get up and move it. I have no problem with that. An area to the left. An area to the left. Cumulative area, which is an area to the left. Now, obviously, what is a 50th percentile? What z-score would a 50th percentile be? It'll be what? What's the z-score to this? Well, no, 0.5. Well, that's the area, but what's the z-score? It's just 0.0. Look at that. Look at the area. Look at the table for 0.0. It says 0.5000. That means it's half a table, half the area is to the left. Now, let's say instead I gave you something like this. I'll go ahead and do it right. What if I said the 95th percentile? 95th percentile. How would that be represented like in P? Like it would be P what? P what? P sub 95. Okay. And could you tell me the decimal for that? 0.95, which is fine. But we were going to say the 0.9500 because we're using our table. So now when I draw this, where would I put my line? Oh, you wouldn't put it here because if you shade only up to here, it's 0.50. So it'd be like somewhere over here. Wouldn't you put it somewhere over here? Right? And you would shade all the way over there. And that's a good representation of the 95th percentile because 95% of the data is accumulated by that time. But now what z-score would that be? See if you can find a z-score for that. So we look for 0.9500. There's a problem here. We have for 1.64, we have 0.9495. And for 1.65, we have 0.9505. Who's closest? 1.64 is closer than 1.65? They're both the same. Yep. They're both equally close to 0.9500, isn't it? No, there's none of them are greater. What you do, you pick the one that's exactly in the middle. Right? So now you know that this z-score here is 1.645. It's a special one we use often. You'll also find that if I gave you this and I said the 5th percentile, what's P5? Can somebody tell me what P5 is represented? And P5 is different from P50. P5, how would you write the decimal? 0. What? 0.5. Very important. That's very different than P50. Different than P50. P50 is 0.5000. This is 0.05. And this here is represented like this. It's a little tail over here. Right? And that there is 0.05. So this comes out to a z-score of negative 1.645. If you went through it. In other words, you're going to look at it and the similar thing is going to happen. You're going to have for negative 1.65, you're going to have 0.495. And for negative 1.64, you're going to have 0.505. You don't know which to pick, so you pick the one in the middle, negative 1.645. This is how we do the 5th percentile. So before I leave you guys, I want to give you like a few notes, and I guess I'll just extend it here, and this will help you for your assignment, because I do have an assignment here. Let me lasso it and just take it over. And next class, I'll collect this, and then we're gonna go ahead and talk about it in class. And then you'll do some more practice, and then I'll go ahead and test you on this. So here's some notes that are important. So your 90th percentile means 0.900. But another word we use is quartile. So your first quartile is your 25th percentile, 0.2500. The 10th percentile is 0.10, 0.1000, I guess you could say, 0.1000, which is P's of 10. And third quartile is P75 or Q's of 3, 0.755, 0.7500. And this is going to allow you, hopefully these notes and this lecture will allow you to, and we're here until when, until 45? Okay, so we got some time to work on it in class. You can come to me, but that's essentially it for this particular lesson. So